Alright, so this video addresses the 5 equations, and I make a big joke. The world can be simplified into these 5 equations, and the word there is almost. It's a paper slide video. And these are 5 equations I think that help us through all our composite shapes in algebra, geometry, algebra 2, and pre-calc. So, one we have to be able to use and quickly recall is the area of a circle. Area of a circle, which I use as A for area, subscript C, is equal to pi times the radius squared. We have to recall over here that a circle has a radius, a fixed center, and an equal distance radius to a whole bunch of points, which make a round circle. Diameter is 2 radiuses, and we have to remember that the area is how many squares fit in the circle. The circumference, or shown here in red, is the distance around the outside, or its circumference equals pi d, or sometimes written as 2 pi r. These are 2 of the 5 equations that have to deal with circles. The second one I like to talk about is a rectangle. And I subscripted as A sub r, area of a rectangle, equals length times width. And we know a rectangle has 4 sides, where the opposite sides are the same length and parallel to one another, and are perpendicular, or 90 degrees, in the corners. Recall that a square is just a special rectangle. I put that note over here. And again, area is simply how many squares fit in. And here I made a 3 by 6 inch rectangle, and I actually drew out the 18 squares. So there are 18 square inches. Now when we have a triangle, which is the next one, we can picture that as simply right in the middle if we put a diagonal in. And again, that develops its formula, which is area of the triangle is 1/2 base times the height. We don't use length and width, or base times height over 2. And here I show a right triangle, and this is the easiest case. The base and the height are both legs because they meet perpendicular. You have to have the height perpendicular to the base. So while a right triangle has the base and height as legs, the obtuse triangle simply has a base, and its height will be outside the triangle. And for an acute triangle, the base is here, and the height is inside the triangle. You may take any leg times its perpendicular distance vertically to get area. When I drew these 3 triangles, you'll notice the bases are roughly the same length. And again, I try to make them all the same height. So again, a right triangle, base and height are on the legs. Obtuse, the base is on the triangle and the height is outside, and on acute the base is on the triangle and the height is on the inside. Circle for 2, rectangle for 1, triangle for 1. This will be the last one. And this is for volume of a prism. And I like to think of it this way. It's area of the base, where the base is the shape that has a match on both ends, times the vertical distance between them, or the height of the prism. So if I have a prism, a rectangular prism shown here, this is, if I call the front the base, the height is in between the 2 bases. In this case, it's length times width for the base times this height, h. If I draw a triangular prism shown here, this top triangle has another triangle on the bottom. That is the base. So I would get 1/2 base times height, times height. Not the same. The 1/2 base times height that begins it is the area of the top triangle. The second h from the prism is the vertical height. And again, we'll apply this in class, and it's just a formula for us to have as a reference. Now, the world has a slew of formulas that we'll look up, and we're not going to worry about memorizing them. And again, volume of a cone is just 1/3 area of the base times the height. It's 1/3 of a prism. Spheres are 4/3 pi r cubed for the volume, 4 pi r squared, where the radius is the distance from the center of the sphere to the outside surface. We can do a rhombus. There are special formulas for that. 1/2 d1 times d2, where those are the diagonals. Again, those are based on triangles. And finally, the one that some students like to learn, it's a parallelogram, where it's just the base times the height between the 2 parallel surfaces from the base. And again, I simply see it as 2 triangles. I do 1/2 base times height plus 1/2 base times height. Again, there are 5 formulas: rectangle, triangle, circle, circumference, and volume of a prism. And again, if we put those in, it will solve almost any composite shape we need to work with for the next couple of years. Again, remember these 5 formulas.